I want to tell you about the universe. What it is, how it came to be, what its building blocks are. I want to tell you how the future creates the past, which then creates the future. But first, I want to tell you about crystals. You might be surprised to know that a crystal isn't an expensive piece of glass or a chandelier in some fancy dining room. The word crystal simply means a pattern that is periodic. Look at this checkerboard pattern. See how it continues to spread out infinitely in each direction? That means it's a periodic pattern. So that's a two-dimensional crystal. This is another two-dimensional crystal. And this is another. You can also have three-dimensional crystals. By the way, this 3D glass is called crystal because its atoms are actually arranged in a crystalline pattern. So, see how I'm projecting this three-dimensional crystal to a two-dimensional image on the sand? See how the 2D projection looks distorted because of the angle of the projection? That 2D image also has a pattern, but it isn't periodic. So, it's not a crystal. But there's a deep connection between the 2D object on the sand and the 3D mother crystal. This distorted 2D pattern is called a quasi-crystal. A quasi-crystal in a certain dimension, in this case 2D, is a projection of a crystal in a higher dimension, in this case 3D. A group of physicists in Los Angeles is working on a new physics theory where a particular 8D crystal, yep, that's right, an 8-dimensional crystal, is projected to 4D at a very particular angle, which forms a 4D quasi-crystal. And from this 4D quasi-crystal, they derive a 3D quasi-crystal, which they believe is the fundamental substructure of all of reality. This 3D quasi-crystal has a fundamental building block, a tetrahedron, which is a three-dimensional equilateral triangle. The size of each edge on this shape is the smallest possible length that can exist. This is called the Planck length. It's 10 to the 35 times smaller than a meter. So you know how your TV screen is broken down into building blocks called pixels? A pixel is the smallest possible indivisible unit of the 2D screen. So think of reality as your TV screen, but in 3D. And think of the tetrahedron as a 3D pixel, the smallest possible indivisible unit of reality. The tetrahedra in the quasi-crystal combine with other tetrahedra, using complex mathematical rules, to fill up all of the space in the universe. Each tetrahedron only has a few specific states in which it can exist at any given moment. And because of the rules of how these pixels connect to each other, if one tetrahedron is in a certain state, this dictates the states of many other tetrahedra throughout all of space. But here's the weird thing. If a certain tetrahedron can be in any one of just a few possible states in a given moment, who or what chooses the state it should be in at any given moment? Well, for such a choice to be made, we need to scientifically, mathematically, and logically bring in a new element into physics. And that element is consciousness. If you're not a scientist, you might be surprised to learn that nobody actually knows the exact value of the speed of light. We have a close approximation, but not the exact value. The closest we can get to measuring it has to do with the precision of our machines. But no matter how precise our machines get, we will never be able to measure the exact speed of light without a theory that tells us what it is and why it is. And none of the current physics theories do that.
Oh, look, Professor Einstein, you look so cute.
So I look pretty here?
Yes, yes.
No, wait, that's my bad side. But if I go...
Ja, das ist gut.
What if I stick up my tongue like this? Bah!
Sehr gut.
Oh.
Our best physics theories, Einstein's theory of relativity and quantum mechanics, both use the speed of light as a starting point. In other words, they use an inexact measurement of the speed of light without explaining why it is, what it is, or why the universe even has a speed limit in the first place. We need a new theory. And such a theory is what the physicists and mathematicians of quantum gravity research in Los Angeles are working on. They call it emergence theory, and it will, really for the first time ever, provide an explanation for the speed of light and the other constants, such as Planck's constant and the fine structure constant. Basically, what is needed is a theory of everything, a theory that explains the very fundamental aspects of reality. String theory, which once held a lot of promise for possibly being a successful theory of everything, has not made any successful predictions. And regardless of predictions, the theory itself isn't actually a theory of everything. It's just not, because it can't explain the speed of light or the other constants. Quantum mechanics and general relativity, on the other hand, do make good predictions, but they don't explain the fundamental constants either.
Professor Einstein, why does the speed of light have the exact value that it does?
Well, to put it plainly, security!
So what clues does nature offer us for what a theory of everything should look like? We've identified 7. Information, causality loops, non-determinism, consciousness, pixelation, E8 crystal, and the golden ratio. A growing number of physicists are saying reality is made of information. What does that even mean? Well, information is meaning in the form of symbolism. A language or code provide this kind of information-conveying symbolism. A very different type of symbol is one that represents itself. Geometric symbols can do that. A cube can represent love, if we say it does, or it can represent, really with minimal subjectivity, itself. Could there be a language or code made out of geometry? What type of information would such a language express? Quantum physics theory and classical physics indicate that reality is made of information, and there is no evidence that reality is made of anything other than information. Many physicists agree with this, and many don't. But those that don't agree that reality is made of information have no explanation for what reality is, if it's not information. Gentlemen?
Reality is made of information.
Nope.
Yes, it is made of information.
No.
Okay, so what is it made of if not information?
Energy.
Energy is information.
That's stupid.
Energy is the potential for a particle to change its position. Potential is information. Energy is information.
No.
It's information. Then what is it?
Not information.
Then what is it?
Not information.
Reality is geometric. A geometric language in the form of geometric symbolism, the type of symbols that represent themselves, might explain how a geometric reality can be made of pure information. Information implies meaning. But what is meaning? Meaning is a comparison. That's what we do. But we do it so fast, we don't realize we're doing it. We look at something and we match it to something from our database. We say, that is a crosswalk. That is a building, not a crosswalk. That is a window, not a building. So meaning is the perception of something relative to something else. So therefore, meaning is subjective and requires choice. Can we get some dramatic music here? Because meaning is subjective, for it to even exist, it needs to be perceived or measured by some form of consciousness. Einstein showed how the past and the future exist simultaneously in one geometric object. So all time exists all the time.
Let me say that again. All time exists all the time. I know that sounds kind of weird and unintuitive, but we have to kind of suspend our common sense. And accept that mathematically, and according to the best physics formulas we have, that actually makes sense. So, let's visualize the geometric object that Einstein spoke about as a block. Remember the tetrahedra, the building block pixels of reality I told you about? Now imagine the entire universe, everything, everywhere, in one frozen moment in time.
Like a single frame in a movie. In this one frame, all of reality everywhere appears frozen in this one position. Let me give you an analogy. In a movie shot on 35mm film, there are 24 frames a second. There's no actual movement in a movie. There's just a sequence of frozen frames. Now remember how I told you about the Planck length of space, which is the smallest length possible? Well, there is also a Planck length of time, and it is much shorter than 24 frames a second. In fact, it's 10 to the 44 times shorter than a second. Okay, so back to our frozen frame of reality. The entire universe in one frozen moment, one frame. But instead of a frame in a movie, it's a frame in all of reality. Now, imagine the next frame. Each frame is different from the previous one, just like in a movie.
See how all frames exist in Einstein's space-time all at once? Okay, now here's where things get really, really weird. We assume that the past influences the future. That's how we appear to experience reality. But when you look at this block, why would one side be the past and one side be the future? Why go left to right and not right to left? Why can't the future influence the past? Take away the names past and future if that helps you think of this concept. So what if the past influences the future and the future influences the past in an endless feedback loop?
So then, the question is, which part of the past is influencing which part of the future and vice versa? And the answer is, all time is affecting all time, all the time.
Hi, I need a drink.
Is this even possible? Can me 20 years from now influence me now, just as I influence her? So can me 5 minutes from now influence me 10 minutes ago, just as me 10 minutes ago influences me as a baby, just as me as a baby influences me on my deathbed? This is too weird to even grasp. But everything we know says this is the way it is. Am I stoned? Okay, so if every moment is co-creating every other moment, both forward and backward in time, then reality would be this massive neural network spanning space and time. This type of network would have one even way stranger quality than anything we've talked about so far. It would be its own creator.
But the fact that all time exists all the time does not mean that the future is written in stone, and we're some kind of programmed animation or something. That's what they used to believe, though. Years ago, it was popular to believe in the somewhat bummer idea of reality being a deterministic program playing itself out.
Light is scattered by electrons and is bounced off electrons.
The famous double-slit experiment ruled out determinism. Look it up if you've never heard of it. It's wild and is one of the cornerstones of modern physics.
But for now, take my word for it. It ruled out determinism and ushered in a new era of non-determinism, or basically, free will.
So, how does free will work?
One of the most surprising discoveries of quantum physics is that reality only exists when it is observed. That literally, particles do not exist until they are observed. Famous physicist John Wheeler, he's the guy who came up with the term black hole, says that reality is made of information, which is created by observation. The observation must be made, he says, by something conscious. And Nobel Prize winner Frank Wilczek said that quantum theory is contentious and obscure, and that it will remain that way until someone constructs, within the formalism of quantum mechanics, an observer, a model entity whose states correspond to a recognizable caricature of conscious awareness. An entity, an observer. So Frank Wilczek is basically talking about an entity, not necessarily a human being or an animal, that is capable of generating information by observing and measuring. But what would that conscious entity be? Well, we definitely know that consciousness exists in the universe. I mean, at least in us humans, right? I mean, I'm conscious, you're conscious, he's conscious, I think.
I'm conscious. I'm conscious.
Consciousness relates deeply to physics in ways not yet fully understood. In fact, consciousness is kind of like one of the least understood things in all of science. Nobody knows exactly what it is. Weird, right? So if reality is pure information, if everything, energy, matter, thought, if it's all information, then it becomes clear that reality deeply ties into consciousness in some way, as if the fundamental stuff of reality is somehow consciousness. Did consciousness and information somehow emerge in a causality feedback loop? German physicist Werner Heisenberg developed the first equations of quantum mechanics using a type of math called matrix theory. He deduced that space and time were pixelated into indivisible three-dimensional Planck length units, just like the two-dimensional pixels on your computer screen.
It's good to be made of pixels.
The mathematics indicated this.
Mathematics. I love mathematics.
Your pizza, Professor.
And pizza. Oh, I love pizza. Especially pixelated pizza.
And interestingly, there was no solid experimental evidence for smooth, in other words, not pixelated, space-time.
Pizza.
Not pixelated. Not pixelated. Pixelated.
We are not pixelated.
Not pixelated.
Yes, you are, morons.
Your mother is pixelated.
This is smooth.
There is no evidence of that. And the mathematics show it is pixelated, so it must be pixelated.
Oh, that's interesting. Bullshit.
It must be pixelated.
Bullshit, 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 bullshit.
On the other hand, most scientists agree that a length can be no shorter than the Planck length, which suggests reality is pixelated.
There is no length shorter than the Planck length.
That means reality is pixelated.
I'm not pixelated! I'm not!
Dude, you're kind of being a little like one of those people who deny evolution because they can't handle the fact their ancestors were monkeys. Are you a monkey? Huh? Are you a little monkey?
We believe that until a quantum gravity theory of pixelated spacetime is discovered, the issue will remain confusing for everyone. What type of geometric code would describe a pixelated reality? 80 years of smashing particles together in particle accelerators, such as the famous Large Hadron Collider in Geneva, have given us a strange clue that all the fundamental particles and forces convert into one another. Like they literally transform from one to the other, according to a process called gauge symmetry transformation. And all of these conversions correspond to a shape. And not just any shape, an 8-dimensional shape. Now this shape forms a crystal. Now remember, crystals are periodic patterns of a certain shape. Like that checkerboard is a 2D crystal made up of squares. So this crystal is of a particular 8-dimensional shape. And this crystal is known as the E8 lattice. To generate that 3D quasicrystal, the substructure at the pixelated fabric of reality, we project this 8D crystal
to 4D. And then we convert that to 3D. Now, just like the basic cell shape of the 3D cubic lattice is the cube, the cell shape of the E8 lattice is an 8D shape with 240 vertices. We call it the Gaussian polytope. When the Gaussian polytope is projected to 4D, it becomes two identical shapes of different sizes. The ratio of their sizes is a unique number, 0.618, also known as the golden ratio. The golden ratio may be the fundamental constant of nature. It is a ratio that is fundamental to circumscribed equilateral triangles, and it's weirdly ubiquitous in the universe, appearing everywhere from the quantum to celestial scales. Ever so interestingly, it appears in black holes.
I don't want to fly into a black hole! I wish I never theorized your existence!
Okay, let's get serious for a second. Here are 3 quick facts for you science heads. The golden ratio is the precise point where a black hole's modified specific heat changes from positive to negative. And it is part of the equation for the lower bound on black hole entropy. The golden ratio even relates the loop quantum gravity parameter to black hole entropy.
Why does this support the claim that the golden ratio is the fundamental constant of nature? Because a theory of everything must unite general relativity with quantum mechanics, and a black hole is where these two theories converge at their limits. Okay, so bear with me through some really weird math right now, and I'll reward you with some amazing footage of John Malkovich getting a pie in the face. There's a type of mathematics called matrix mathematics. No, not that type of matrix. Matrix math is the type of math that quantum physics uses in its formulas. Without getting too technical, this is an example of a matrix. A matrix is just a group of numbers that are arranged in columns and rows. And there's a certain amount of combinations for these numbers inside the matrix. Like if a matrix has 4 numbers inside it, there are 24 different possible combinations for those 4 numbers. Quantum mechanics uses matrices that are binary, so they only contain various combinations of 2 numbers. Each of these combinations of numbers has a value. It's called an eigenvalue. Some eigenvalues are called trivial. These are values like 1, 2, and 0. And some are called non-trivial, and those are all sorts of more complex-looking numbers. So, here's the interesting part. Where's that interesting part? Oh, yes, here. The highest probability non-trivial eigenvalues that show up in binary matrices are, ready for this, the golden ratio and -1 over the golden ratio. So we now see a deep link between black holes and quantum mechanics, because the golden ratio appears deeply in both black hole physics and in quantum mechanics. Okay. Good job bearing with me. So, here's your reward. John Malkovich getting a pie in the face.
No, I don't want, no. But I'm not John Malkovich.
Pie! The golden ratio appears to startling accuracies in many other ways throughout the universe, in scales both large and small. It is so prevalent that its existence simply cannot be looked at as coincidental. In the past, the appearance of this ratio has usually been ignored by scientists because they had no way to explain it. So interest in it was considered the stuff of amateur scientists. But now, for the first time, a rigorous quantum gravity theory is being developed, which predicts the golden ratio's existence, literally, everywhere.
So what would a theory of everything look like that answers these 7 clues we just presented? Information, causality loops, non-determinism, consciousness, pixelation, E8 crystal, and the golden ratio.
So we think reality is a mosaic-like code or language at the smallest scale of reality possible, which is called the Planck length. Particle accelerator data tells us that all particles and forces relate to one another according to a higher dimensional crystal called the E8 lattice. But reality appears to be 3D. So we project a slice of this E8 crystal down to 3D, which produces a quasi-crystal code or language. And that allows these geometric symbols to build up to the ordinary world of particles and forces that we see around us. Now, this geometric language has rules, but it also has syntactical freedom like any language. And that requires some notion of a chooser to choose the free steps in the language. Now, the notion of randomness doesn't work so well when it comes to codes because meaning starts to break down. Besides, there's no decent experimental evidence for randomness in nature in the first place. A universal collective consciousness is one answer, but that sounds New Age and religious. Now, nowadays, a good number of physicists discuss the idea that our whole universe is actually a code-based simulation in some fantastically powerful quantum computer in another universe. Now, if true, then by the same logic, that other universe where the computer running the simulation of our universe would also supposedly be a simulation in another universe. So the idea is a little shaky, but it's being discussed seriously by a lot of credible people. But it turns out that a universal collective-like consciousness of some sort may be physically inevitable. Now, we don't need to anthropomorphize this idea or make it religious or spiritual. To follow why, let us start with the idea of the collective behavior of cells in your body, each a single-celled microbe living its life. A long time ago, only this sort of cellular life form existed here on Earth. These little guys were not too smart, but they did choose what direction to swim and could chase nutrients, reproduce, and run from dangerous things. They made choices with their very simple systems of environmental awareness and desire to survive. Then they self-organized into colonies that were smarter as a group and had more environmental awareness than the individuals. Eventually, animals such as humans emerged. Sophisticated forms of awareness and consciousness now float on an ocean of 37 trillion living cells, self-organized as a human being. It is specifically the laws of physics that caused electrons and quarks to self-organize into 81 stable atoms, and from there, into human consciousness. And physics places no upper limit on the amount of energy and matter that can self-organize into conscious systems.
Physics allows the possibility of all the energy in the universe to eventually convert into a single conscious system that is itself a network of other conscious systems, a massive, technologically based collective consciousness.
Given enough time, anything that can happen will eventually happen. By this axiom, this system of universal consciousness has already emerged somewhere in the frames of space-time ahead of us. Because it is possible, it is inevitable. In fact, according to the evidence of retro-causality time loops, that inevitable future is co-creating us right now, just as we are co-creating it.
When humanity discovers the theory of everything, it will usher in a new age of prosperity. For example, clean, cheap energy, leading to the eventual elimination of poverty. As a nonprofit, quantum gravity research relies on crowdfunding to support our scientific progress. Even a $5 donation is meaningful and moves this mission forward. To participate in the adventure, visit quantumgravityresearch.org and click on Support Our Work. And please spread the word by sharing and posting this video and follow the journey on Facebook, Twitter, and Instagram. Visit quantumgravityresearch.org to get more information.
These words of wisdom, although written by my decaying hand, shall remain imperishable through time. May they be imbued with the medicine of immortality.
A few miles west of the Nile, and just below the tip of its delta, lies Saqqara, the necropolis of ancient Memphis, center of Lower Egypt from the days of the pharaohs through to the time of Egypt's Roman conquerors. The ibis, the graceful black and white bird in which the god Thoth showed himself, no longer visits the Nile at Memphis, but when the Ptolemies and their Roman successors drank from the holy river, the god's bird still came to its banks in great plenty. Wisdom is eternal, even if people are not. The Kybalion, while only published in 1908, is a manuscript that claims to be the essence of the teachings of Hermes Trismegistus, who, as we've discussed before, is believed to be our old pal Thoth. We should be clear that there are several different texts here worth exploring. There's the older Corpus Hermeticum, which is a huge ancient body of work in itself, along with the Emerald Tablets of Thoth the Atlantean and the Emerald Tablet of Hermes. But these writings do not actually make any specific references to the laws and principles that we're exploring today. And so we have the Kybalion, which is supposedly based upon ancient Hermeticism and is argued to be an elaboration of an ancient, unpublished Hermetic text of the same name, one which humanity has not yet actually found. While it's healthy to approach it with some skepticism, the profound wisdom of this text needs to be taught and explained. The Hermetica speaks very highly of cosmic laws, critical to be understood in order for our own liberation and transcendence. And that's why we've created the 2021 Almanac of the New Age. If you're interested in connecting with the celestial and personal cycles in order to start the new year off with an exceptionally high vibration, check out this book. You'll find links in the description. And with that, let's now dive into the Hermetic principles. The Kybalion was written by unknown authors, known simply as the Three Initiates. But the most common theory is that it was authored by a man named William Walker Atkinson and some others, who was a famous American occultist and pioneer of the New Thought movement. In the first couple of pages, it says that it will only appear to you when the time is appropriate and you're ready for its wisdom. So I guess that means we're ready for it en masse, huh? Because there's more than a few videos and articles talking about it now. For the most part, it discusses the structure of the spiritual world and outlines the three great planes of existence: the physical plane, the mental plane, and the spiritual plane, all of which are broken down into several lesser planes, which are kind of like astral black keys like the ones on a piano, each having their own vibration and frequency and are inhabited by different kinds of spirits and entities. Another aspect of the wisdom is found in its teachings of alchemy. It discusses aspects of spiritual and mental transmutation and how you can alter your vibration or frequency to move into these higher realms, interact with spiritual entities, and attain the wisdom of Hermes himself. The subject that has made the Kybalion a legendary book is its discussion of the 7 Hermetic principles, which are like the laws that govern the universe according to the Western mystery tradition, the foundation of many schools of esoteric thought today. Much like how physicists observe the universe, to the Hermetic mystics, they believed that the universe runs on natural laws. Apples fall, birds fly, things live and die. But when we take time to understand these laws, we can use them, and in some cases even leverage them, to transform life as we know it. Perhaps one day we can push against gravity to fly, or simply use the knowledge that one day we might die to live better lives. As it's described, whenever this wisdom resurfaces in culture, it acts as a catalyst for a creative renaissance, revolutions, and cultural regeneration. These 7 laws were some of the most influential systems of thought to the Renaissance and medieval philosophers, which even today can expand horizons, broaden possibilities, and aid one in the pursuit of a fuller, happier, more meaningful, and longer life. And so, as we go through these principles, remember that they were potentially first thought of thousands of years ago, despite only being codified recently in history before any modern science verified their unusually accurate and esoteric claims. The Kybalion even devotes a chapter to each principle and goes into what it's really all about. And we especially recommend going deeper by reading this book if you haven't already. It's a favorite of ours.
Principle 1, Mentalism.
Much like in the Corpus Hermeticum, this axiom embodies the idea that all is mind, something today we know as idealism. Basically, Everything that happens is a result of a mental state which precedes it. For anything to exist, thoughts had to form first, which then form physical reality or manifestation. But it goes even deeper than manifestation though, for the principle of mind is rooted in the idea of the God mind, that the universe itself is the mind of God, or going even bigger, that the universe is a thought in the mind of God, that all phenomena of life, matter and energy of the material universe are thoughts of an infinite and universal living mind, which means all things share a connection to the fact that they exist within the mind of God or the all. Perhaps this could take the form of a field, as is thought of consciousness. In other words, when you view everything you think and therefore do as an interaction of a thought with another thought, you develop an understanding of the first principle of mentalism, which allows you to grasp the laws of the mental universe. This law ultimately says that it is our consciousness that allows us to interact with reality.
Principle 2, correspondence.
This truth discusses the idea that there is always a correspondence and link between the events in the various planes of existence. In fact, this law is where we explore the legendary phrase, as above, so below, to much greater depths. In a nutshell, if something is happening on a physical level, chances are there is a relationship to a like energy on a higher frequency too. And if something occurs solely in the physical, if that's even possible, it will have an effect on the other planes of existence. By observing the principle of correspondence, we can come to know the whole of the universe by exploring the relationship between the higher and lower nature of things, and learn that harmony exists only when we have a good balance between all of the dimensions of our being.
Principle 3, vibration.
In short, nothing rests. Everything in existence is in a constant state of motion and vibration. Even things that appear motionless and still, like a rock on the ground, is still moving at a molecular and atomic level and beyond. To quote Walter Russell, "In the wave lies the secrets of creation." It explains that the distinction between manifestations of matter, energy, mind, and spirit are all just the result of different vibrational frequencies. The higher a person or thing is on the scale, the higher the rate of vibration. In fact, spiritual alchemy in the Kybalion is described simply as the practical application of this principle. To change one's mental state is to change vibration. You can sometimes do this by an effort of will, by deliberately fixing the attention upon a more desirable state. Ultimately, even thoughts have their own rate of vibration and can be controlled like tuning an instrument to produce various results of self and environmental mastery. As your understanding of vibration, frequency, harmony, and resonance gets better, so too shall your power over yourself grow.
Principle 4, polarity.
Following in our last principle, this one says that everything has an opposite. While this might seem out of the ordinary for a spiritual text that talks about unity and one mind, this one refers to how the unity manifests through creation. The whole thing is like Newton's first law of motion, that everything has an equal and opposite action and reaction. All manifested things have two sides, two aspects, or two poles. Opposites are identical in nature, yet different in degree. Extremes meet, and all paradoxes can be reconciled. An obvious example is a hot and cold tap, both waters being aspects of temperature, varying only in degree. There is no clear crossover moment when hot stops being hot and starts being cold, and vice versa, with no absolutes on either end too, especially since the quality of hot and cold are relative to your own perception. If it's cold outside, jump in a freezing lake for a few minutes and get colder than the average temperature outside. Suddenly that cold air is actually kind of feeling pretty warm to you. This one is quite important since it suggests that we can change the polarity of a degree of emotion by recognizing it as a spectrum and choosing the degree which best suits our needs.
Principle 5, rhythm.
This one builds upon both the principles of vibration and polarity, as it states that everything is manifested as a measured motion, to and from, outflow and inflow, a swing backwards and a swing forwards, just like a pendulum. This law also reminds us that there is a rhythm between every pair of opposites or poles. Learning from this principle allows us to transition from one pole to the other, and not necessarily need to go to poles of extreme opposites. It also arguably controls the cycle of life and death, creation and destruction, rise and fall, and of course, manifests in our mental states. Know that things you lose will come back, and that things you own now will also one day disappear.
Principle 6. Causation.
Again, we find ourselves overlapping with previous laws, and it makes sense that they'd fit together. This principle states that there is a cause for every effect, and an effect for every cause. It also argues that there's no such thing as chance or coincidence, that it's merely a term indicating already existing causes that we can't recognize or perceive. The empowering use of this principle is to make the conscious choice to rise above the plane of thought you're currently on and become your own cause, and not just an effect of others and the situations you find yourself in. In other words, strive to act rather than react, or be mindfully responsive at best. If you want to be good at something, you need to practice it every day, as opposed to resigning yourself to merely reacting to the consequences of not having done any self-work and then experiencing the problems that inevitably arise when you're not pursuing your highest calling.
Principle 7. Gender.
This principle explains how gender is manifested in everything, but this doesn't necessarily relate to sexual gender or how you identify yourself. It's more about the masculine and feminine energies that lead to creation and procreation in the universe. And if you haven't seen our episode on masculine and feminine energies in general, you can always check that video out right after this one. It doesn't refer to someone's physical sex, nor does it suggest that someone of a certain sex necessarily has a matching mental gender. In actuality, ideally, you would want to have a balanced mental gender, embodying both the sacred masculine and divine feminine. Gender and these two polarities of energy exist on all planes of existence and represents different aspects on different planes. Everything and everyone contains these two elements or principles. The Kybalion explains that the divine feminine is more receptive, facilitating new thoughts, concepts, and ideas, including the work of the imagination. The sacred masculine, on the other hand, works more by giving out or expressing, and rules over the will of an individual and helps put things into action. It is said that there must be a balance in these two forces. Without the feminine, the masculine will act without restraint, order, or reason, resulting in chaos. The feminine alone, on the other hand, will constantly reflect and fail to actually do anything, resulting in stagnation. With both the masculine and feminine working in conjunction, there is thoughtful action that breeds success, which tells us that both the feminine and the masculine fulfill each other. Ultimately, choosing the middle path between these extremes is the key to using all 7 Hermetic principles to full effect and achieving lasting self-mastery without straying too far from the path. At the same time though, we must remember that these are only principles. By themselves, they're kind of useless, but when you creatively apply them in your life, you can achieve any endeavor you dedicate yourself to and have your own personal renaissance. The best way to understand them is by experiencing them for yourself. And so with that, thank you so much for joining us today. Remember to try and apply the wisdom of these teachings in your life, mostly by asking questions like, have I ever experienced mind over matter? Have I ever attracted something into my life repeatedly by obsessing over it? Or have I ever dipped my fingers in water so hot that it shocked my nerves and felt cold at first? All of these kinds of questions can be answered with the Hermetic principles. So have fun trying them out. Until next time, toodles!
Hey, welcome back to Clean Cut, where we can talk about the truth about just about anything, as long as we use logic and common sense. I thought we'd go over a few issues raised by various comments I've received. Today, is there such a thing as empirical reality? Someone brought this term to my attention at one point, and it piqued my interest because the word empirical is usually used to represent a method of gaining information, the empirical method, which involves observation and experience as opposed to logic and theory. For example, there's empirical knowledge, which is any information gained through our senses or through some scientific experiment. Methods like deduction and mathematics don't produce empirical knowledge because those types of knowledge are abstract. Many people today put more stock in empirical knowledge for a variety of reasons, but there's no good reason to. It's not more reliable and no easier to verify than logical or mathematical knowledge. It just depends more on the senses, which in a way makes it less reliable. While we get most of our data through our senses, sense data can never be known with 100% certainty as logical and mathematical truths can be. That leads us to the other side of things, reality. Reality is usually defined as an actual state referring to things as they really exist, rather than a mere ideal or notion of those things. In short, reality refers to how things really are, as opposed to just how we're perceiving them. Since the word empirical refers specifically to how we gain information, and the word reality refers specifically to not how we gain information, we'd really have to have a good reason to put them together. Unfortunately, there doesn't seem to be a very good reason. I've seen an article that talked about empirical reality, but it was just referring to a philosophical study of how many things are mind-independent in the view of René Descartes. A very unreliable website used this term, but was only referring to the reality that can be deduced from repeatable observations of the senses, meaning, rather, the parts of reality that can be discovered through the senses, since the senses don't deduce anything, properly speaking. So, on the whole, a thing can be empirical, or it can be reality, but it doesn't seem that it can be both. Next, is the Bible sufficient? That's all for now, so keep asking questions, and thanks for watching.
The year is 2100. Human population has reached 10 billion. As temperature rises and ice caps continue to melt, rising sea levels have caused huge swaths of land to be permanently underwater. Major cities such as London, New York and Mumbai no longer exist. Millions of people have had to leave their homes, city population have risen, and stepping outside means breathing in extremely polluted air and endangering your life. Once fertile farmland has become unworkable as soil turns into dust. The number of people not getting enough food increases, rivers and seas are polluted, the provision of clean water an ever-increasing problem. This sounds like the plot of a dystopian novel, but it could end up being real. Since the Industrial Revolution in the late 19th century, the human population has exploded and is now growing at an exponential rate with no signs of slowing down. More people demand more resources and create more pollution, an ever-increasing impact on Earth. Humans cause pollution by burning fossil fuels. We are reliant on them for transport and electricity generation. Burning fossil fuels releases carbon dioxide into the atmosphere, which is a greenhouse gas. Increased greenhouse gases cause an increase in average global temperatures, known as the greenhouse effect. This is linked to climate change. Some areas of the world are getting wetter and others hotter and drier, and these changes have an impact on ecosystems and biodiversity. If you want to learn more about biodiversity and why it matters, watch this video. For example, warmer weather in the Arctic and the subsequent melting of the sea ice has an effect on animals that are living there. The polar bear is no longer well adapted for living in its habitat and is an endangered species. Humans also require resources. Large areas of forest are cleared to make more room for agriculture or to mine minerals or for growing other resources like palm oil. The removal of trees is called deforestation and has an enormous impact on not only the local ecosystem but the entire planet. Ancient forests, such as rainforests, are unique ecosystems. They can support a high biodiversity and are home to species that can only live in that habitat. For example, in Borneo, rainforests are being cut down to make room for palm oil plantations. The species that live in the rainforests cannot survive in the plantations. They may not be able to find food or shelter, like orangutans, who are an endangered species. You can find out more about endangered species and how conservation is helping them by watching this video. Forests provide services to the planet. They are important in the water cycle, recycling fresh water across the globe. Trees are also able to take in and store carbon dioxide, which helps regulate the Earth's temperature. As well as burning fossil fuels and deforestation, humans also create lots of waste. Sewage, pesticides and fertilizers enter the water. They may contain toxic substances that can kill organisms and impact on whole food webs. Pesticides can accumulate in the tissues of organisms and stay in the environment for many years before being broken down. A combination of a growing population and a throwaway culture we also have increasing demands for dirty, wasteful landfill. But let's end on a happier note. There is some hope. People are coming to realise the impact we are having on the environment, and governments are aiming to cut down their reliance on fossil fuels and putting schemes into place to help protect forests and endangered species. So, in this video, you have learnt about how human activity has a negative impact on the Earth because of burning fossil fuels, deforestation, and creating waste.
If you liked the video, give it a thumbs up, and don't forget to subscribe. Comment below if you have any questions. Why not check out our FewSchool app as well? Until next time.
Causality describes a relationship between two or more things where a change in one thing causes a change in another. The essence of causality is a phenomena being dependent on some other effect. As such, causality is a connection or linkage between states or events through which one thing, the cause, under certain conditions gives rise to or causes something else, what we call the effect. Causality forms a fundamental and pervasive part of our perception and interpretation of the world around us. Equally, our ability to act in the world depends upon our grasp of causal relationships between things, that is to say, the way things act and interact. In everyday life, humans and other animals rely on the assumptions of causality literally every waking second. And in academia, much of science is the study of systematic cause and effect relations. Perceived causality involves the process of inductive inference. The basic process of induction is one of inference from a set of things that have something in common to generalizing what we observe about them as being true for all instances of that kind. We generalize from a sample of previous experiences to a whole population. We project past uniformities in our experience onto future events through expectations. We've seen a ball move off in the opposite direction every time that it was hit with a bat in the past, so we assume it will be the same in the future, and this assumption through inductive inference creates the perception of there being a causal relationship between things. Thus, although cause and effect appear a central characteristic of our world, they are in fact simply associations that we make between events. The philosopher David Hume illustrated how there are no necessary connections between events in the world. In his words, all events seem entirely loose and separate. One event follows another, but we can never observe any tie between them. They seem conjoined, but never connected. We perceive cause and effect, and then extrapolate from that to infer cause and effect relations about things that we cannot see, such as black holes, subatomic particles, or events in the future. Of course, when we generalize, we're going beyond the evidence by the definition of generalizing. Our conclusion covers things that we have not or cannot know. The rising and setting of the sun in the past cannot guarantee it will rise and set tomorrow. Conceptions of causality can be roughly divided into linear and non-linear. Linear causality is the idea that cause and effect follow a single direction between events, from A, the cause, to B, the effect, and that for every effect there is a single or limited number of causes. Non-linear causality is the idea that causality may follow a bidirectional path, from A to B, or from B to A, or even both at the same time, and that there may be an unlimited number of causes for a given effect. With linear causality, there is seen to be a direct link between cause and effect. Cause precedes effect in a sequential pattern. Linear causality has a clear beginning and a clear end. There is one or a limited number of causes for any given effect. Additional linkages of causes or effects create a line or a sequential domino pattern of causality. The central ideas behind linear causality are captured in what is called the Axiom of Causality. The Axiom of Causality is the proposition that everything in the universe has a cause, and is thus an effect of that cause. This means that if a given event occurs, then it is the result of a previous related event. if an object is in a particular state, then it is in that state as a consequence of another object interacting with it previously. The philosopher Plato stated this when he wrote, "In addition, everything that becomes or changes must do so owing to some cause, for nothing can come to be without a cause." The three criteria for establishing linear cause and effect are correspondence, time precedence, and non-spuriousness. The first step in establishing linear causality is in demonstrating correspondence or association. This means asking the question, is there a relationship between the independent variable and the dependent variable? Correspondence or correlation means that the cause and effect occur within the same unit of analysis. For example, if being exposed to the cold is more likely to make you sick, then people who are exposed to the cold should be more often ill. Time precedence means that the cause must occur before the effect. If one wants to say that being well educated causes one to earn a higher salary, then the cause of being educated must precede the effect of earning a higher salary. A spurious or false relationship exists when what appears to be associations between the two variables is actually caused by a third extraneous variable. This is captured in the saying, "Correlation does not imply causation," a phrase used to emphasize that a correlation between two variables does not mean that one causes the other. For example, a false correlation might be drawn between the amount of ice cream sold and the sale of sunglasses. There is a hidden variable of temperature that is causing both to change together without there being a direct cause and effect relation between them. This linear causality is a keystone of the analytical reductionist approach, and searching for these linear cause and effects has formed a central part of modern science. This process of inquiry is conducted by defining a closed system and then isolating it from its environment to control variables. Cause and effect interactions are searched for as an explanation for how elements in the system behave. Within this paradigm, cause and effect relations are seen to move in one direction, that is from the bottom up, and not the reverse direction. Lower level phenomena are seen to cause higher level events. For example, in asking why the body functions as it does, we would refer to the internal constituent parts of the organs and tissues to derive an upward causal relation, instead of looking for a cause within the system's environment, which would be a form of downward causation. Linear causality equally leads to the conception of determinism, in that it defines a closed system and reduces the number of causes to a limited set acting in a single direction. Reductionism and linear causality try to reduce the cause of an effect to a single or limited number of determinants, and the fewer the number of component determinants that we identify, the greater the determinism will be. Nonlinear causality sees causation as flowing in a bidirectional or multidirectional pattern. Nonlinear causality involves cyclical processes where one thing impacts another, which in turn impacts the first. Although this chain of events leading to feedback may be mediated through several events or take place over a prolonged period of time. Nonlinear causality is part of the holistic synthetic paradigm that looks at systems within their context or environment. As such, it is much more focused on downward causation, where there are many or even possibly an infinite number of interacting variables. The holistic paradigm posits that effects can be the product of a great many causes. To gain a full understanding of the effect, we need not drill down to find a single cause, but instead look at multiple different factors and how they interact to give rise to the outcome as an emergent phenomena. Whereas in the linear model, the relationship between cause and effect is seen to derive from one of the components affecting another. Within the systems thinking approach, it is the relationship between the parts that is seen to create the effect. For example, from this perspective, it is not that one chemical substance causes another to react in a particular way. It is, in fact, the type of relationship between them that generates the emergence of a particular outcome. and thus there is no direct cause and effect. It is instead an emergent phenomena of a relationship of interdependence. With nonlinear causality, cause and effect can flow in both directions through time. However, this requires information and some kind of control system being involved. Purely physical processes result in a unidirectional flow to causality, from the past to the future, and not the other way around. But once there is a control system involved, this can define some future desired state, the system's goal, and then this can affect events in the present based upon information about the future. For example, whether I spend lots of money now may be contingent upon whether or not I think I will get paid at the end of the week. Thus, with nonlinear causality, causes for events may be derived, at least partially, from the future. But this would only appear to be possible under the condition of goal-orientated behavior, where current events are conditioned and controlled by projections surrounding some goal in the future. In a coming video, we'll dig further into nonlinear causality as we talk more about indeterminism, downward causation, and equifinality.
Alright folks, in this video we're going to discuss the nature of science. In other words, what science is, how science works, right? So we'll talk about what science is, what it isn't. We'll talk about things such like the scientific method and how science really works. And then we'll finish up talking about science and religion. So, what is science? Right? When you think of science, what do you think of, right? Well, I'll tell you what I think of. Science as a tool or a method. A tool or method for what? A tool or method to investigate the natural world. It's a systematic process, a logical process that we use to investigate the natural world around us, right? Science uses data and observations to discover how our natural world operates. Science is not, however, an all-powerful entity, right? I mean, if you think about how science is sometimes portrayed on TV and in our society, right? It's one of two things. It's either science has shown us this and science has proven that. Well, that's great. I'd like to meet this person's science. Where are they, right? Science, so scientists use the tools, the methods of science to investigate the natural world, to figure out how it works, right? There is one big underlying assumption that all sciences make, not just geology, but physics and chemistry and all of them, right? And that is that the world and the laws that operate in our universe, the natural laws, the order, right? They have been the same through time. In other words, they are not constantly changing, right? In other words, if you mixed chemical A and chemical B together today, or if you did it 7 billion years ago, you would get the same results, right? If that is not true, then nothing in science is true. But that is one of the big underlying assumptions. And from what we can tell, that has been the case, right? So how does science work, right? It works through a process called the scientific method. Now, this is a general kind of process for investigating the world around us, right? It's a general procedure. Not all scientists go about science the same way, right? So the way I science as a geologist is going to be quite a bit different than, somebody doing nuclear chemistry or something like that, right? But in general, there are kind of methods and steps, right? It's a systematic set of observations and experiments that are performed over and over. This is the iterative process, the iterative part of the process. Iterations, if you're familiar with anything from computer science at all, means over and over and over and over and over. And that's how science works. We don't just do something one time and then we're done, right? It is also a peer-reviewed process. Now, what does this mean? This means that your research, your methods, your findings are put out there for the rest of your peers, your scientific community and colleagues to look at, to analyze for themselves, to respond to, and then to perform those experiments again to make sure that you did everything correctly, right? So it is kind of a self-correcting, self-governing process. Very, very importantly, science operates on this principle that we call falsifiability. And that means it must be able to be proven false. Now, let me give you an example of something that is non-falsifiable, right? In your bedroom lives a little leprechaun, but every time you turn to look in his direction, he disappears and becomes undetectable by all scientific means, right? This is a non-falsifiable statement. You can't prove me wrong, right? Science requires falsifiable statements, falsifiability. You must be able to prove it wrong in order for you to use science on it, right? Now, I know you've seen this word before, too. This is a hypothesis, right? This is the root of the scientific method. So this is the basis off which science operates, right? So what is a hypothesis? Let's take a look here. A hypothesis is basically a tentative explanation based on data and observations. So not just a random guess, right? A tentative explanation based on data and observations and things that you know, right? We then test these hypotheses using the scientific method, right? And again, there's several variations of this, but in general, the scientific method is as follows, right? You make an observation. This sparks a question. The sky is blue. Why is the sky blue? Right? You then do background research. It's very important to do background research because this is another big part of science. What if somebody has already looked into the question that you have, right? You should start from what other people have found and disproven and ways that they have investigated and what their findings have been, right? There's no need to reinvent the wheel over and over again, right? So science, it builds upon itself, right? We build upon the knowledge and the information has been gained throughout the whole history of humankind, basically, right? So do some background research. And let's say in this case, nobody has yet investigated why the sky is blue, right? So we did our background research. Nobody looked at this question. So we're going to come up with a hypothesis, right? This is, again, a tentative explanation based on data and observations, right? So we form a hypothesis. My hypothesis for why the sky is blue is there is a giant lake up there, right? Now you kind of laugh and smile, right? But let's say that this is my hypothesis, right? We then need to test our hypothesis, right? And we need to set up the test in such a way that it will prove that it is possible to prove our hypothesis wrong. If we don't, it's called a null hypothesis. That's where, either way that the test or your experiment comes out shows you nothing, right? So we want to set something up. We want to set up a testable hypothesis, right? So my testable hypothesis for why the sky is blue, right? So I said the sky is blue. My hypothesis is it's because there's a giant lake up there. So to test my hypothesis, I am going to set up an experiment where I shoot a rocket up into the air, right? Now, my results will either be that the rocket comes back wet, which would support my hypothesis, or the rocket comes back dry, which means there's no giant lake in the sky, right? So let's say we test our hypothesis, right? Now let's analyze the results. We shot the rocket up in the sky, right? It comes back, the rocket is soaked. Obviously, I have just proven that there is a giant lake in the sky, correct? No, not correct, right? I have just merely supported the hypothesis, right? I have not proven, I have failed to disprove my hypothesis, right? So we test our hypothesis, right? And we can either accept, right, which doesn't, again, mean that it is correct, just means that our data from our experiment has failed to disprove this hypothesis, right? We could then also reject the hypothesis, right? And that's another very important part of this, right? So again, this is an iterative process. This can happen over and over and over, right? And then there's also a peer-reviewed process. So I take my data, I take my observations, right? My hypothesis is the sky is blue because there's a giant lake up there. I tested this by sending a rocket up into the sky. It came back wet, and according to my results, that supports the idea that there's a giant lake in the sky. Another scientist reads this and says, well, I think maybe it was just raining that day, right? Or there was a big cloud above you, something, right? So he repeats the process. He sets up a test. He shoots a rocket up into the sky, and the rocket comes back dry, right? He has now rejected this hypothesis, and this is very important because, future scientists now can look and spend their energy and time and money researching other reasons for why the sky might be blue. We're not stuck with this, there's a giant lake in the sky, right? We have disproven that now, and that is very, very important, right? Being able to prove something wrong, right? That's how you have to set up your hypothesis. One of the results from your test must prove your hypothesis incorrect, right? And that's very important because the more of these incorrect hypotheses that we eliminate, right? So now we don't have to look in the direction of a giant lake in the sky. Now we can focus on other things. The more of these reasons we eliminate, by definition, you eliminate looking in the wrong direction. You focus in more and more on what must be correct, right? Even whether we ever get there or not, right? So what makes a good hypothesis, right? First of all, a good hypothesis will explain new data that's been collected or found, or new observations that have come about after your hypothesis was formed, right? They will also predict the outcome of new experiments. In other words, the predictions agree with the observations, right? So prediction is a huge thing in the sciences, right? Having predictive power is huge. It means you are most likely on the right track as far as your hypotheses and stuff like that, right? So outcomes of hypothesis testing, right? You can support or accept the hypothesis. And again, as we just mentioned with the lake in the sky example, this doesn't mean necessarily that you're right. It just means that the outcome of your experiment supports that hypothesis, right? You could also reject the hypothesis. And this, of course, means that the outcome of your experiments shows that that hypothesis is incorrect, right? And again, rejection is not a bad thing. It eliminates an entire direction of investigation. Right now we can focus our energy on other things, and the more directions we eliminate as incorrect, again, the more we tend to focus in on what must be correct. Right? So what is a scientific theory then? A scientific theory is a coherent set of well-tested hypotheses. What do I mean, a coherent set? They're looking to explain some various aspect of nature, right? The theory of gravity, the theory of evolution, the theory of plate tectonics, which we'll talk about in a couple chapters here, right? Theories also make good predictions, right? Again, predictive power, huge in science, right? And they stand up to all scientific scrutiny, right? Theories stand up, the theories that we currently hold have stood up to all scientific scrutiny to date, right? Not scrutiny from Billy Joe Bob, but scrutiny from the scientific community, right? And that's important because, as we learn new things and eliminate new directions, right, we can adjust and modify these theories to those new information, right? What then is a model? Well, a model is a combination of hypotheses and theories, and this is actually to represent a system or represent how a system behaves, to model a system, right? And the idea here is to make predictions, right? The one you'll be most familiar with are weather forecasting models, right? So in these models, behind these models are a whole bunch of theories about atmospheric circulation, surface wind circulation, right? Cloud formation, I mean, all this stuff. I'm not a, meteorologist. So, but behind there are all these theories and hypotheses that come together, right, to create this model, right? And they run these scenarios through, and they predict how the weather's going to be, tomorrow, the day after, the week after, right. So, and obviously they're always 100% correct all the time, right? Well, no, of course not, because, a model is only as good as the theories and the information behind it, and we don't know everything, of course, we'll never know everything, right? But then this is also why you might get a little bit different predictions from different TV stations, right? One might be using a certain model, one might be using a different model, right, that they use to figure out their weather forecasting, right? So those are models, right? Now let's talk a little bit about scientific laws, right? Now scientific laws are statements, right? These are statements of relationships that exist between things, right? So the universal gravitational law, right? How gravity operates, right? Or the ideal gas laws, or in a couple chapters we'll talk about Steno's laws. And what we're really saying is these are statements of relationships that exist between things in our universe, but there is absolutely no mention of the how or the why, right? So those are the realm of hypotheses and theories, right? And here's how they work together, right? The scientific law describes what phenomena happen, right? And then the scientific theory explain why the phenomena occur, and then hopefully if your theory is on the right track, you'll get repeated successful predictions as the outcome of these theories, right? And this is the area of where we have scientific models, right? So, question to you. Name a couple things that science has been able to prove right. I'll let you think about it for a minute here. Think of some of those scientific theories, right? How about gravity, right? Science been able to prove that, right? Evolution. Plate tectonics, coming right back to geology, right? Big Bang. Which of these are correct, right? Or which of these, has science been able to prove right? The answer is nothing. Nothing. Science proves nothing right. That is not how science works. That is not the nature of science. Let me tell you how science works, folks. It operates on the principle of falsifiability, which means science cannot prove things right. Science can only prove things wrong, right? And this is the power of science, right? So does it make scientific theories weak, or does it make them strong? I would say this makes them strong, right? The theories that we currently hold today, right? Well, they're not perfect, right? They have withstood all scientific challenges to date. And the more challenges a theory withstands, the stronger that theory is, right? Remember with my example about the giant lake in the sky, right? We disproved that there's a giant lake up there, right? So now we have to look at a different direction, right? The more of these directions we can prove incorrect, again, the more we tend to narrow in on what is actually correct, right? So, if you've got a pet theory that you think is great, right, the best thing you can do for it from a scientific standpoint, throw everything you have at it. Try to disprove your theory. The more you try to disprove your theory and the more that withstands that, the stronger and stronger that theory becomes. And again, this isn't, we don't just, come up with a theory and then never test it again. I mean, this is tested all the time, right? Think about how many scientific theories you are independently testing, not even thinking about it. When you start your car and drive it to the, grocery store and social distance and all that good stuff while you're there, right? I mean, just think about how many different scientific theories and models go into just driving your car to the store, right? So, what about science and religion? Very first video I'm making for the class here. Am I going to go there on the first day? Oh, absolutely, right? So, here in our society, science and religion are often viewed as at war with each other or at odds with each other, right? So therefore I've got my microscope fighting my cross down here, right? But are the two mutually exclusive? Are they necessarily exclusive? And the answer is no. No, this is what we call a false dichotomy, right? A false, dipolarization of the issue, right? As a matter of fact, this current kind of, anti-science fundamentalist young earth creationism has come about really since the 1940s. Before that, there really wasn't, there were some, issues here or there, but it wasn't, such the big science versus religion thing as it was now, right? In fact, some of the early great scientists and geologists were very religious people, right? And also, there are hundreds of thousands, if not millions of religious scientists all over our globe, right? The vast majority also of scientists, including myself, have absolutely no problem with religion. There's those outstanding ones, or outspoken ones like Richard Dawkins, right? But that is very much not the norm, right? Most scientists have absolutely no problem with religion, right? And let me tell you a few other things besides, let me put it like this here. Let's see. So, let me go to paint. Paint. There we go. All right. Check this out. So, one of the things that people often say is the reason that science and religion don't interact well with each other, don't play well with each other, is because one is the realm of, by definition, the natural world, science, right? That's all that investigates the natural world. And religion, of course, by definition, lies in the supernatural, right? So some people will say that they can coexist peacefully because what they call the separate spheres, right? If I could draw a perfect circle here, I wouldn't. We'll call this one science, right? I love my writing, right? And then here is another sphere, right? That we'll call religion, right? Right? And so this would be the realm of the physical world, and this would be the realm of the, or this would be the natural world, this would be the realm of the supernatural world, right? And never the two shall meet, and that's why they can kind of coexist together. That's not really how I see it. I more view it like this, all right? So let me draw a big circle here, all right? And this we'll just call, I don't know what you call it, truth, reality, the way things actually are, right? In our world. And this little bubble here, this is what we can know and what we can investigate with science, right? Now, it's growing, right? The more and more we discover, and the more technology and the more scientific breakthroughs we make, right? That bubble is growing, but it's never going to be everything, right? I mean, there's going to be stuff we definitely can't understand with science, right? And, we'll never get to know if there's, not through science at least, if we've ever gotten everything 100% correct, right? But, we're doing pretty good, I think, right? The cars make it down the road, our planes fly in the sky, right? All of this good stuff. And all of these physics and these chemical properties, they depend on this natural world, of course, having always existed with the same properties as it does now since the beginning of the universe, right? Now, religion isn't the only thing that science can't test, right? Because science lies in the natural world. It relies on us having those specific properties of science, right? And all the physical and chemical laws, right? Physics and chemistry. Physics is chemistry. Chemistry is physics. Physics and chemistry are basically everything, right? Math is the expression of those, right? Since the beginning of our universe, right, have been the same, right? So, based on that, here's a few other things science cannot test. Anything that happened before 0.0001 seconds after the Big Bang, right? Time and space did not exist. Physical laws, right? The matter as we store it did not exist. We cannot test that with science, right? And according to astrophysics, which sometimes gets weirder than religion if you really get into it, string theory and all that, says that we probably actually live in a multiverse where there are multiple parallel universes together, and maybe they're only the millimeters apart, and when they touch, that's when the Big Bang happens, and yada, yada, yada. But in these parallel universes, right, they wouldn't necessarily have the same physics and chemistry. They might have different elements, different physical and chemical laws, right? We wouldn't be able to use science there either. We could develop something akin to science, but we would have to start all over from the beginning, all right? All right, folks, hopefully you enjoyed this little video. We'll see you next time.